Now presenting ASTM 698, Standard Test for Laboratory Compaction Characteristics of Soil Using Standard Effort, presented by the University of Arkansas. For this test, you will need ASTM 698, a compaction assembly, standard Proctor rammer, mixing tub, bowl, lubricant, spoon, straight edge, beaker, scale, oven, and a water content container. Without the collar, measure and record the mass of the mold with base plate. Obtain approximately 2.3 kilograms of soil that passes the number 4 sieve and place it in a mixing tub. This equation can tell you the mass of water you need to add to be at your target water content. Estimating the optimum moisture content from previously run Atterberg limit tests, determine the approximate water content value to start compacting at by subtracting the initial water content. Next, pour the soil from the bowl into the mixing tub and add water homogeneously. Thoroughly mix the test fraction and then use a scoop to select a representative soil sample for each test. In order to facilitate removal of the soil after the test, we applied lubricant at this point. It's important to note this is a deviation from the ASTM standard. Now compact the soil in 3 layers, or lifts. Place soil in the mold and spread until it reaches a uniform thickness. Hold the rammer vertically and begin with the cross pattern outlined by ASTM 698. Proceed to apply the rammer around the outside of the mold. Be sure to apply blows at a uniform rate and ensure uniform compaction. Remove material from around the outside of the mold and draw a crosshatch pattern in the top to ensure lifts stick together well. Before adding the second lift, add the collar to the mold. Proceed to add a second and third layer, following the procedure outlined for the first 2 layers. The third layer of pre-compacted soil should extend halfway into the collar. Twist off the collar and trim the mold with a straight edge. Determine and record the mass of soil, mold, and base plate apparatus. Remove the mold from the base plate and remove the material from the mold. Obtain a representative portion of the soil for use in water content tests. Tests completed both above and below the optimum water content will result in a good compaction curve. Using values from before and after the test, the total density of the soil can be calculated using this equation. After obtaining the total density, one can calculate the dry density using the water content. One can convert between dry density to dry unit weight using a conversion factor provided by ASTM. We can now form a Proctor curve, the impetus of performing the Proctor test to begin with. After running several Proctor tests at different water contents, different dry unit weights will be produced. This allows the maximum dry unit weight and optimum water content to form on a Proctor compaction curve. Using the specific gravity, a zero air voids curve should also be plotted.